If you've ever built a carrot feeder, then you're surely familiar with this little guy, and you know that it sucks. So when we started doing HVAC, one of the first things that we decided to do was go with the larger servo. But still, there's reliability problems with these, so they have to go too. And we've done that. That's right, no more servos at all. You might be thinking, that's kind of the norm, how would you get away from the servo? And with some clever software and some clever hardware, I'm going to show you exactly how we've overcome this and really up the reliability of our automated filament changer system. But first, a word from our sponsor today. Raid, Shaft, PCBWay. PCBWay offers custom PCB prototyping services at a reasonable price with a really fast turnaround. I had my turtleneck PCBs in under a week from them delivered DHL. They also offer PCB assembly services, so if you have a complicated surface mount project that you don't really have the skills or the tools to do yourself, they can take care of that. They also have CNC machining, sheet metal, and 3D printing services. And wildly enough, they can even take care of injection molding parts for you. What's actually lesser known, though, is they have a shared projects page where you can find things that other people have uploaded and shared, and you can actually download the files, modify them, and tinker with it yourself and have them made and delivered to you all in one spot. And if you're just getting into PCB design, it's absolutely worth stopping by their website and checking out all the information they have available so that you can learn the skills you need to have a successful project. The two things that you need to go serverless on a system like this is one, some clever software, and two, a buffer. Now when I say a buffer, I don't mean a spaghetti monster box. I mean what you see like on the back of a Bamboo P or X series, or I'll show you a clip of this one in action as well. So basically the function of a servo has been to enable coasting. That way once the filament gets to the toolhead can just passively draw it through the system. And the problem really comes from these things are just not very consistent at engaging filament. We've tried and tried, and I know with the carrot feeder people have had nothing but problems with them. You can get them to work, but they just are not so reliable. So the alternative to that is never disengaging the filament path, instead syncing the extruder with the tool head while it's printing. Now that comes with its own problem. No matter how hard you try, there's going to be a variance between your feeding motor and your tool head. One's going to be pulling harder than the other. And how do you overcome that? Well, use a buffer. Needing a buffer, I started working on one, and about the time that PCBWay delivered my PCBs for it, I found this, and it shipped really quick, and it looked like an interesting solution. A toolhead buffer is not really what they have made over at Mello. Don't get me wrong, this thing is super cool, and I'll show you how it works, but it's not exactly what we need. This is actually intended more to just offload high drag situations from the toolhead, and it does a really good job of that. And it also can be used to aid in loading and unloading your printer. It's got two buttons on it. It's just hooked up to 5 volts, and it can push the filament around. How they're offloading the drag on the toolhead with this is if the toolhead is pulling hard, it's burning up the filament, so this closes and it automatically feeds more. You'll notice this is just hooked up to a power supply, not even hooked up to a printer. This is constantly running itself, and it tries to maintain this buffer at about the same distance. If I hold it out, it'll start rewinding. This is very cool, but in a perfect situation, this is only ever going to help with a coasting system, and a coasting system only happens with servos. So this is not what we need. Also, this doesn't have any form of clog detection. It does have run out and breakage detection, which you can hook up to your printer. So Annex Engineering has developed this for their trad rack system, and it's a very nice, very compact little form of a toolhead buffer. You get about 10 millimeters of travel here. And basically what this does is it just gives the toolhead a little bit of room of free coasting. There would be an end stop here, and if the filament gets tight, then it knows to feed about 10 millimeters more so that the toolhead can experience less drag. It's a very elegant, very compact solution, but there's no error checking in that. So this is what I have made. I call this the turtleneck, and what it can do is, one, it can offload for about 35 millimeters of filament. So if you're printing super fast, the system can keep up with the toolhead and not cause any artifacts from strain on the filament. The other thing we can do with this is error detection. So if the toolhead is supposedly pulling filament and this isn't moving one way or the other, there's a clog, breakage detection, etc. There's some clever tricks in here. Something else interesting is, again, I didn't know about this when I was designing this. Mello opted for a very small linear rail. It's like a drawer slide, which honestly to me seems kind of overkill. Whereas I just relied on the PCB itself to have a rigid and free moving slide for the buffer tube. But yeah, with this we can take care of variances in feed rates between two different extruder motors, which in turn enables us to get rid of the servo altogether. As far as 8-track is concerned, I have to still design a new extruder module that has a latching system so that you can load the cassettes properly. But for time's sake, I literally just changed the guidler and put a tension screw on it, and we started messing with the software that way. Here's that turtleneck PCB that PCBWay was kind enough to send me a few of. Absolutely beautiful quality. Side effect of not having servos, it enables things like this. So now we start getting into the software of this. What you just seen happen was they went through each lane and checked the status of it. You can see that this light went red, there's nothing there. This one is blue, it's loaded into the toolhead, and these two are ready to go. So this is the output of what you just seen. It went through, it checked each lane for its status. It knows that lane 4 is loaded into the toolhead, so it synced it with the extruder. And then it output ready. You can see there's nothing tool loaded in the Switchwire's Raven right now, but it went through the same check. So right now we're looking inside the automated filament changer config. This is the type right here. We're setting it up for multiple kinds. It's got the Raven. If you got a carrot feeder, you can run it with this too. We just have some basic variables. This is where you set all the things specific to your printer. We've got your long moves, the speed, acceleration, short moves. Just really just going to depend on your hardware, whether or not you have a hub cutter, how to do that. If you're doing poops, parking, wiping, all of that, this is where you enable those things. Tip forming. These two right here are the most important that you need to know. This is the filament sensor, the distance to nozzle, and this is how far it has to travel from the hub to the toolhead. If you set this to 0, then it is just going to go this distance at this speed until it finds its way there. If you want to learn more about this project specifically, be sure to join the Patreon, and it'll get you exclusive access to behind the scenes channels in the Discord, and it's a good way to support what we're doing here. I also want to just let y'all know that the full bill of material kits for the turtleneck buffers will be available on my website, as well as donation tabs. Oh, and this is called the box turtle.